everybody, we're gonna get started in just a couple of minutes, not minutes, probably 1 minute. It's day 3. If you have joined us for other Safe+Sound week webinars, welcome back. If this is your first one, welcome. Just a couple of notes for anyone new. If you have any questions throughout the webinar, please feel free to drop them in the Q&A box and we will be happy to answer them. And by we, I do mean Stephanie. And then the other thing to note is all of the slides and a recording of the webinar will be sent to you via email. If you are wanting to get CEUs for this course, we're going to drop a form into the Q&A at the end of the webinar. For those of you, if anyone was in the webinar yesterday and you didn't have time to click on the form and you don't have my email will be up at the last slide and you can just email me and let me know you were in there and we'll get you CEUs for the Breathe Easy webinar. Thank you. Sorry. Wow. It's been a long day. So now it's really been a long week. So thank you guys for hanging in there with us. And we're really excited about this webinar. So I'm going to turn it over to Dr. Lynch.
Yes, thank you, Laura. I'm Stephanie, and I work for OHD. If you haven't been here the past 2 days, I work for OHD as the Senior Technology and Research Manager. I'm an industrial hygienist by training and also practice. I was an industrial hygienist up until I started working here, which I guess I still am, but it's definitely a different function to be sort of behind the technology. So today we're going to talk about air sampling, which obviously if you were here yesterday and you're using respiratory protection, then you have inhalation hazards that you're concerned about in your workplace. And that means that you would need to do air sampling to quantify the exposure of your employees before you would ever even know what type of respiratory protection that you would need to use. And if you haven't done that or didn't know that, then I strongly recommend that you get that handled because that's the way that you're going to comply with OSHA. Okay. We've started every other talk, if you've been here with, like, why is this important? Yeah. And of course, I again just feel like if you are here, then you already know that the most important aspect is protecting your employees. If you don't know what they're exposed to, then you obviously aren't going to be appropriately equipped to protect them. So air sampling is a really important part of your hazard assessment that you should have performed at your workplace. It's going to help you figure out, which process or processes or product is causing. I mean, you're already going to have some idea of where you need to focus your efforts, but it's going to help you really narrow down if you need to, what is the contaminant of concern? What are the levels that we're facing? And then what are the controls that we're going to implement? Obviously, in an ideal world, we're working from the top of that hierarchy and going with eliminating these exposures in some way, but obviously that's not feasible in a lot of these situations. And unfortunately, we do often get down to that very bottom part, our last resort, which is personal protective equipment. But this is going to quantify any employee's exposure to whatever contaminants you are concerned with. And it's also going to help you if you are able to implement some of those higher level controls like engineering or substitution, you can do subsequent air monitoring to confirm that that control is working. It's obviously with respiratory protection, you're functioning from a different perspective. Okay, the objectives of your sampling are obviously to identify your air contaminants. I sort of mentioned that you're already going to you should already have some idea of what's going on at your facility because you're going to know all the stuff that you have. I have seen people be surprised by an exposure. Unfortunately, with an employee complaint is typically how that sort of stuff comes up. And that's not how we want to find out, right? That means someone has been exposed. But identify your air contaminants, be able to get employee exposures. For the person who you are sampling, you're going to get a really, really great idea. But obviously, it would be quite cost prohibitive to sample every single employee every single day to get that exposure. So it is still an estimate. You're going to be able to characterize your workplace And then you're gonna hopefully also be able to identify and then also quantify your emission sources, so where these things are coming out, whatever they may be. I really do have to say things because it could be anything, particulates, gases, vapors, whatever you might be giving off at your facility. I mentioned already that it can help check your controls, whether they're working or not, and then it is required to comply with certain standards. Both OSHA and then maybe the EPA. Okay, you know, I do this a little bit differently in the classes where people are able to respond immediately to me. You know, how do you identify air contaminants? But hopefully you're in your head going, oh, you know, like yelling something out, because what I hope that you're really yelling out is your SDS. So I mentioned that you would have gone through a hazard assessment. As a function of that hazard assessment, you are going to be going out and looking at every corner of your facility, and you're identifying everything that people are working with, because that's part of how you know what your people are facing, and it's required when you have personal protective equipment, or to ensure that you don't need personal protective equipment. Like OSHA is going to expect you to have done something, a hazard assessment of some kind, and your SDS is going to be your most valuable resource for what your people are exposed to. And the STS, luckily, since we've gone to the global harmonization system several years ago now, the SDS is organized in a very specific way. And this little section here, hazard identification, is going to be the most helpful for your air monitoring program. So it's going to tell you, what the hazard is, what the damage, what the damage can be done, what damage can be done, and just pretty much everything you need to know for identifying that hazard. So we're actually doing that here at OHD in just a couple weeks. I'm reviewing some SDSs right now for some things we work with in our warehouse, and we're going to perform some air monitoring to quantify the exposure, because we have some new processes that we've just implemented using both 3D printed parts, so like a new sort of process for us with obviously different exposures than what we've had historically, and then with some soldering of some brass. So those are some things that we're going to be doing. So I'm reviewing SDSs right now. So the key sampling questions, the big sort of whammy one is how are you going to do it? Which method are you going to use? So what type of sample needs to be taken? And that's based on how the work is performed. Do you want the sample to be representative of whatever exposure is happening when a person is performing their actual work? So what type of sample is that? Is it a short-term, grab sample? Is it a full shift sample? Where should the samples be taken? This is, it depends on what type of sampling you're doing, and again, what the job is. How many samples should you take? I'm not even sure if I finished my thought earlier about, it's cost prohibitive to sample each person each day. So oftentimes we'll group people based on a similar exposure that they would be experiencing based on having similar work tasks or similar work area. And that's going to help you figure out how many samples should be taken, which personnel you're going to take, and for how long are you going to need to sample them. And a lot of that is going to come from your sampling and analytical method that you're luckily going to be able to get from your lab. So only validated methods from NIOSH or OSHA or any other recognized authority, which I'm not particularly familiar with what you might be using globally, but NIOSH and OSHA, it's going to tell you, what you're using to collect your sample, which type of media you're going to need. It's going to give you your sample volumes. So that's going to tell you for how long, right? You're not going to want, if you're pulling at a particular flow rate, then you're going to be able to know how much volume you can collect, and you're going to, plan accordingly. So your flow rates, how long you're collecting, how you handle certain things. There are some types of media that are going to come and need to be refrigerated, or trying to think of other, I'm sure there are a lot of other means of handling things appropriately, and then how those things are going to be analyzed. Again, now we're so lucky, like being an industrial hygienist is actually so much easier because you're going to do this most likely through your lab. So even sometimes, this sort of, we in the interest of full disclosure, in case you haven't been here the past few days, OHD does sell air monitoring equipment. We sell the Gillian line of air sampling products. So, we prefer when people are getting their own equipment and doing their own air monitoring, but there are now labs where you can go, and if you maybe don't do enough sampling to justify the purchase of in-house equipment, you can go and your lab will supply you with everything you need to include that pump. Sometimes they've gone ahead and pre-calibrated. I don't like that process. We'll talk about how important I think calibration is and that you should be doing it pre and post, but there are times where the lab can do all of that. And so it's going to give you, your analytical method is going to define all of this, but oftentimes now you're using the lab. So this is just an example of that method. This is the one for silica from NIOSH. So it's telling you here, what kind of cyclone and filter, what flow rate you need to do based on the cyclone that you're using. It's giving you a minimum and maximum of those liters, so that volume of air that you're going to be pulling. How you're able to ship it, which is just routine, how many blanks you're going to need to provide. So really just everything that you need, at least if you have some familiarity with sampling to start. And the lab gives you usually a guide past this, like how to really set up your sampling train. That stuff is very useful. I do want to say that we're kind of I tried to design this PowerPoint so that when you get the PDF of the PowerPoint, you're going to just at least be able to tell what's available. But we're not deep diving into what is maybe some of the really important parts, which is like walking through an actual calibration, setting up your actual sampling train. That can be a really confusing aspect, but that's something that you really need to do with the equipment and with it in front of you. And so that's what takes a couple times. I have actually seen people even do something as simple as put the filter media on backwards. It says inlet, and that's where the air is supposed to be entering. But people do get kind of just like turn around in their head and they think, well, inlet, okay, maybe that's the side that I put onto the pump, right, into the pump. So I have seen that, but anyway, okay. So types of samples. You can do screening samples that are usually going to be taken with real-time monitoring equipment. And that's going to help just provide a generalization of what your concentration is at maybe a given point in time. Maybe there's like a process that kicks on intermittently and you just want to get like that worst case scenario of that time. Usually this is going to help you just distinguish if you need to perform full shift sampling. This is typically how you're using screening. So then, do we need to do full shift? And it can be done either in the work area, or it can be done the same way you would do full shift sampling, just like for a shorter duration. And that just depends on the process. Like the way that we're setting up our sampling for that soldering operation is that we're doing a short-term exposure because they only do it for a short-term amount of time, but we're doing it with it clipped to them like a personal, so it is a personal sample, but you get what I'm saying? It's not a full shift sample because they're not doing it for the full shift. We want to see that worst case. So it's really a screening way, but we're doing it on the person. So full shift is going to be a long-term sample. This is typically taken with an air pump and your media, and you're getting, you're estimating exposures over the shift of that employee. This is what you're going to then take and compare back for OSHA compliance. These are some admittedly terribly outdated pictures of screening devices, but these are screening devices. So detector tubes, particle counters, indoor air quality monitors. Oh, buddy, man, if you have to do an indoor air quality survey, I am so sorry for you. There is about 20% of the population who is going to be unhappy essentially in any indoor space. And it can be very difficult to then do an indoor air quality monitoring session to figure out if there is a real concern or if this person is just going to be unhappy either way with how that is. There are a lot of legitimate concerns, but if you've done one, then you know what I mean. It can be very difficult. For full shift air monitoring, this is when we're doing it over the entire work shift. We're collecting air around the worker's face. We're doing it in what they call the breathing zone. And you want to make sure that you're hooking it up so that it doesn't get in the way of doing the job. This can be a little bit tricky, that tubing. You want to make sure you've got it hooked up so that it's not going to get kinked. You also want to make sure that your pump is capable of handling if it does get kinked. That can be something that's very helpful. And then you need to make sure your pump's going to provide a reliable flow rate so that you're confident in the volume that you've collected. So attached in that breathing zone, it's going to be then the pump itself. So you've got the media up in that breathing zone, and the pump itself is going to be connected down typically on the worker's belt. You're going to check whatever air volume is specified by your method. And then just like with any other sampling, we want to keep an eye on it. This is often sort of a tricky process. You're usually sampling several people at once, so you're kind of having to rotate through. Make sure that you're keeping track of which processes they're sort of getting exposed to, and make sure you have familiarity with the site and what else is going on there, because otherwise you could get results that you can't make any sense of. And if you can't make any sense of them, then you're not going to be able to do anything about it. Another thing is you do have to, this is just, I hope that this is less common, but you do have to sort of make sure that no one's tampering with their sample. I have unfortunately seen where people will take a smoke break and then they'll be blowing their smoke into the media. Like, I guess, people just sometimes think something's funny, or maybe they want it to result in some sort of overexposure. I don't know, but people do strange things. So you do have to keep track. This is an example of just, good placement. These are actually sort of this is sort of, yes, that's good. I would probably try to even get it a little bit closer, and I wouldn't want it tilted out like that. And then this is very bad. This is not so good as an understatement here. This is the complete wrong way to draw your air in, but that's fine. We just want to show an example of what's not right. So I already mentioned that the lab is going to be honestly your greatest resource here. So even if you do have your own equipment, you are going to use that lab to get your media, and then to analyze your samples, because only those laboratories that are using the NIOSH and OSHA methods and then are accredited by the American Industrial Hygiene Association should be used. And AIHA does have a list that you can go reference online. The laboratory, like I mentioned, is going to send that sample media. It's going to include the pre-weighted filter cassettes. And that's just hopefully going to, and like I said, even more than that, that's just hopefully going to make your sampling as easy as possible. They've tried to really idiot-proof it. And, people are people, so it's not quite there yet, but we're doing the best we can. So this, again, I am going to walk through this example just because these are the conversions and the important aspects that you're going to want to be familiar with. These are typically just things you fill in on the form, but if you don't, on a just basic level, understand this part of it, then you can come off looking like a real dummy if the lab does mess up something, or if you get results that obviously don't make sense. You need to have some ability to recognize that. So here's our example. This is a mass of 0.35 milligrams of silica found in the laboratory of a 5.5-hour sample collected at a flow rate of 1.7 liters per minute. So you're first figuring out your sample volume in liters. So you've got that 5.5 hours. You're then changing that to minutes. So that's just with this conversion. We're all familiar with that one. And then you're multiplying that. And this is because you need to be in the same units, right, for minutes to cancel out. So you've got that 1.7 liters per minute. That gives you 561 liters. You're doing another simple conversion with your cubic meters. So this is another one you should be really familiar with, especially if you are sitting for either the CIH or CSP exam. And if you have, then this is a very important one. It's also just important to understand for your air sampling. So you're taking that 561 liters, and that becomes 0.561 cubic meters. So that air concentration then during the sample period, this is just coming from your results, right? The mass of 0.35 milligrams was found. So you're taking that milligrams and putting it over that cubic meters. That's going to give you your 0.62 milligrams per cubic meter. Now you want to figure out the 8-hour time weighted average. So you're taking what you just calculated, and like I said, I'm walking you through this because I think it's important just for you to have a basic understanding. But typically, these are just numbers that you fill out on a lab form and it walks you through it, and either you're calculating it or they're calculating it, but just really want you to know, so if you get something that's crazy, you'll understand. So the 8-hour time weighted average, you're taking what you just calculated and you're multiplying that by the 5.5 hours that you sampled over the 8-hour shift. And this is the circumstance if there was no other exposure, right? We're assuming no other exposure and there shouldn't be any other exposure. So then you get the 0.42. This is what you're then comparing back to the standard. So just a quick time weighted average reminder, this is another really important formula. I mean, really just in our profession generally, but obviously if you want to sit for a certification exam, this one's going to be an important one. So you're taking the time that you spend at a particular concentration and you're multiplying each of those together and then adding them all up. And then you're multiplying it, you're dividing it by the total time, which for a time weighted average is typically going to be that 8-hour time period. So in this example, we would end up with this 94 parts per million, and this is that time weighted average that we would be comparing back to the standard. When we have multiple exposures that have the same toxic effect, we just do this a little bit differently. So we're taking whatever we found as the exposure and we're comparing it back to the permissible exposure limit, and then we're adding them all up and we're making sure that that cumulative exposure is less than 1. So I've got a quick example here of what we're doing. So if we've got these established permissible exposure limits, and don't take these as, this is an example, but I'm not even sure when I would have put these in here. I'm pretty sure this is a resource from OSHA. And as we all know, OSHA can be really slow to update stuff. And this might not be what you want to reference. You might want to, or you should, reference the most conservative regulatory, referenced exposure limit. So usually the ACGIH TLVs, right? OSHA is kind of the bare minimum standard. But at some point, these were the OSHA permissible exposure limits. And then if we had these 8-hour time weighted average exposures for these, for each one referenced here above, we would then just take each one you saw, so the 5 parts per million divided by that permissible exposure limit. So right, we measured the 5 and then we're dividing it by the established exposure limit. And we're doing that for each one. And if you added those all up, so after we divided, we then add them all up and we get 1.07. So 1.07 is greater than 1, and that's an overexposure. So what if you got 0.99? How do we feel about a 0.99?
Pretty close.
That's pretty close. I would say we're either redoing some monitoring or we're doing some more investigation to figure out, like, was that some sort of worst case scenario or like maybe not, right? Was that actually a best case scenario? We can anticipate higher exposures. That's close. I would say further investigation is needed. That's where we're down.
What's good? What's a good one?
I mean, it's kind of a judgment based thing, but I would say once you're getting like below 0.9, I would feel a lot more comfortable. But yeah, when you're at 0.99, that's real close. When you get to 0.9, you might go, okay, we've got enough distance, right? It's not a long runway we're working with to go up to 1, honestly. Okay, I learned this from my dear friend Andy Bragg as a way to simplify how we talk about air monitoring. It can be overwhelming. Obviously, we've just covered like a big meat section, and it's a lot. It's heavy stuff. So, but it's really boils down to 3 components. You got your pump, you've got your calibrator, and you've got your media. And if you can figure out those 3 things, then boy, you're well on your way. So our first key component is our pump. And so the pump that you're going to select is based on the flow rate that you need. So gases and vapors, those are going to be sampled at a low flow rate typically, and our particulates are going to be sampled at a, like, quote, higher flow rate, so that those particles are going to be able to be captured effectively onto that filter. And then this lower flow rate is so that you're allowing time essentially for those gases and vapors to be adsorbed onto whatever material you're using. This is a graphic that I got from a really good friend of mine. our colleague Dylan. And I liked the way this works. So if you had a nice little wind going at 5 miles per hour, and you're looking at how the feather behaves, and then you're looking at how the leaf behaves, there's different behavior, right? The feather's going to be able to, because it's lighter, it's staying airborne longer. And that's just kind of a good way to then think about the difference between how gases and vapors, this is just like a way to hopefully conceptualize, because I've seen different things, and this is just one of the ones that I enjoy. The one you hear a lot is with particles, how it matters, like the speed, how the particle's behaving. So one of the things, like you're on the interstate, you've got a semi truck and a sports car. They're coming out to an exit, and the exit has quite a sharp turn. For that semi truck to make that turn, they're gonna have to slow down a lot more than the sports car to make that turn. So yeah, so that's a way to think about like how these particulates are behaving. So you want to make sure that you're accounting for that. The method's going to tell you, but just understand that that's why it sort of matters. So high versus low flow. Again, I put a lot of stuff on these slides just for your reference to hopefully, if you go back, you do need to do something, you're going to be able to sort of look at some examples and see some of the accessories that are there. And we're going to kind of just rock through a lot of stuff. So some of the pump performance features, these are the things, and I mean, as far as I know, any of the pumps are going to offer this. Gillian's got good stuff for constant flow and back pressure. I'm sure that all of our competitors do too. But so is there an internal mechanism to compensate for any restrictions that might happen to your flow? I talked about kinking the tube, stuff like that. Are you able to compensate so that the pump itself will make some correction to keep that flow constant so that you can have confidence in the volume you've collected? And then back pressure. So when you introduce your sampling train, the filter media, and as stuff then collects, our filters become more efficient as they collect things on them, right? Because there's less path to go. So there's going to be some back pressure. What's the maximum pressure drop that your pump that you're using is going to be able to handle? That's going to be something that you want to make sure you understand. And that your pump manufacturer understands, wherever you're getting your pumps from. Your second key component is your calibrator. And so I, again, cannot emphasize the importance of pump calibration. If you have not calibrated your pump both before and after use, then you do not really know how much volume of air you collected, and that means that your sample is, basically useless. It has nothing to reference back to, and so you're not gonna know. So calibrating your pump is so that you can calculate that total air volume and have confidence in it when you're able to submit it to the lab. And then the laboratory is going to use that total air volume to calculate those airborne concentration levels, which I showed you how they're going to do it or how you can do it, so that you can have confidence in the calculations that you receive back. Okay, these are just some quick tech tips. So let your pumps run for a bit before you start calibration, and this needs to be with them off of the charger. And let that flow stabilize. You also want to make sure that your pump is calibrated exactly how it's going to be used. So you want to basically set up your pump with the media in line. You want it all set up how it's going to be used in the field. And so then you're going to put your calibrator on, and that's how you're going to get that flow rate. That's how it's going to calibrate it. You can see how that can be so important, right? Introducing the tubing, introducing the filter media, all of that is going to impact how the pump is pulling. And that's how you're able to then adjust your pump appropriately. Then you're going to use a clean set of media to do your actual field measurements. So you've got one for calibration because you're making sure that you're putting everything in line, but then you go use a clean media when you go out into the field. Okay, your flow rate, if any of you have done this type of sampling, air monitoring, then you understand that it can be very difficult to get it, especially with some of the older pumps, to exactly the flow rate that's specified in the method. That is not as important as you being sure that you know exactly what that flow rate is. That is the more important part. And you just need to get it as close as you can to what the method is specifying. You want to take a running average. This says 3 flow measurements. Anytime I've done this, and maybe I'm just like a psycho, I really don't know, but I do 10. I've done 10. So I do 10 flow measurements and make sure that they're within that 5%. Honestly, if they're not within very close to each other, you're going to notice them. If you're then pre and post averages also differ by more. So you've done a pre-calibration, post-calibration. If you compare those, and those are both averages, if those are differing by more than 5%, then something's wrong. Your pump was drifting a lot. You're gonna have a lot less confidence in that sample. So have some awareness there about that. So set the pump and sample, like I said, like it's already ready to be placed on the worker, right? So shout out to SKC, because I did steal some of their visuals just to be representative of what's out in the market. But you attach the calibrator to the open end, the inlet of the sample media, and this is what I mean. So this is already, I mean, this looks like a ridiculously short amount of tubing. This would be much longer in the real world because you would have it probably over the worker's shoulder. But you'd have this filter media in line. And I do think it's important to have the tubing be representative too, just make sure, I mean, why introduce anything to be different? And then you attach the calibrator and you're running to get your flow rate. So some sampling devices, there's PPIs, which we'll discuss in the media section, that are amazing replacement for cyclones, but some of them are going to need an adapter, calibration adapter, to be able to calibrate in line, which you need to calibrate in line. So just be aware of that. So that's just a tech tip there. And your lab would be able to, they would send you what you needed, or they would have done the pre-calibration. So your third component is that sampling media. And just understand that there is so much, there's so much here that I couldn't really possibly cover everything. But I did try to at least put everything I could think of just into the PowerPoint, so you can at least go back and reference and go, okay, well, there is, something for that, there's something here. So first thing I want to do is just define particulates. So when we look at our sampling media, the first category is our particulates. And that's our dust, our fumes, our mists, and our smokes. And this is all of the particulate stuff that you might need to collect. There's also fibers. So fibers like asbestos, this is all based on their length to width ratio. So if your length to width ratio is 3:1 or longer, then it's a fiber. And they need to be at least that 5 micrometers or longer. And so asbestos fibers are going to be sampled on a 25 millimeter MCE filter. So probably if any of you have done this, then you would be familiar with this, which I used to do this all the time before any sort of demolition that we had when I worked at UAB. And there's a whole thing there. But asbestos is going to use a different fiber, a different filter. Fibers are going to use a different filter than what you might see otherwise. Your sampling and analytical methods are going to tell you, like I said, which type of media you need to use. And then that's what you're going to follow, right? And sometimes there can be like different types of cyclones, whatever. There are different ways of sampling. So one of the distinctions that you'll hear is closed face versus open face. So closed face is going to be when you have the inlet piece of the filter. I wish I had a more up close thing here, but essentially it's where this bottom cap is still in place. So you've got the inlet. I'm sort of assuming we're going this way, but maybe this goes this way based on this diagram. I think this is the inlet. So this place is still there. Otherwise, if you were doing open face, these, like this type of filtering media, will actually pop apart, and you would be able to do open face with that inlet piece removed. And so then, right, you've still got it connected to the outlet and then coming over and connected to the pump. With the ones for fibers, same idea. This has like a cap right here, and this is either in place or not. Actually, I think this one you just have to be not. But open face is with the entire inlet open. So closed face, you've got this cap on, and I assume there are types of this where you're going to do open face. And then with asbestos, it's always, I think it's always open face. It says this is what's used. I'm pretty sure that's what's always used. At least I don't remember ever doing it the other way, but that doesn't mean I couldn't be wrong. with your filters, when you get them, there's either going to be matched weight filter cassettes. So one filter is exposed, one is not, and then the difference in the weight is the weight of the collected sample. Or you can do a pre-weighed filter, which has one filter that's been pre-weighed by the supplier, and then they're gonna use that as the reference. So the difference then is the collected amount. So either matched weight, where you've got these two, one's exposed, one's not, or pre-weighed. They've done a pre-weight of one. Okay. So note here too, the lab is going to do a pre and post weight on the same balance that they used to give you the highest confidence in your sample. As far as our size selective criteria, when I talked earlier about like the car and the semi-truck going through, this is what we're talking about with size selective criteria. So there's a total dust measurement that you can do, and then there's a respirable dust measurement that you can do. And that's based on how these particulates behave, and then which fraction of that dust is actually respirable. So when we're concerned about respirable, we have to switch it up a little bit, and we have to introduce either this cyclone, or we have to use the PPI, which we'll cover a little bit later. So with total dust, you get your dust, it's captured on a 37mm filter, loaded into a cassette, and then connected to your pump that's going at least 1 liter a minute. You want your filter to be the appropriate, size. Again, this is what your lab's going to provide you with, and the samples need to be collected in that breathing zone. So a lot of sort of, hopefully you're kind of getting the idea of what it's going to do. But this is just a picture of that breathing zone again, and how this. So this is these are the actual filters inside of this cassette, and then based on how I'm viewing this, I see this as the inlet, and then this is the part that's going to be connected to your cyclone or tubing that's then coming down to your pump. So respirable dust, this is also typically collected onto the PVC filter, but before that, you're going to have a particle size selecting device. So that's going to be either your cyclone or your PPI. So total or respirable dust can be collected. So there's going to be industrial hygiene samples for both of those. Like there's a method for total dust, and then there's going to be method specific for your respirable dust. The cyclone is going to be what's used, or your PPI, which we'll also discuss, to separate that respirable dust from the total dust. Obviously, if you're only concerned about the respirable fraction, then you're not going to want those other parts of dust to be included in your analysis of the weight. So that cyclone is separating it out, it's taking out all the larger particles, and then you're only getting that respirable fraction onto your sample to then weigh as your exposure. So this is how it's working. Air's coming through a slit in the side. That's going to create the cyclonic action, and through a means of centrifugal force, your large particles are going to fall out, and they'll fall into a grit pot. The problem with this method is that you have to make sure that cyclone stays in the right orientation. If the employee were to bend over, for instance, and past a certain point, then you're actually going to have all of that dust dump onto the filter, at least momentarily, and you're going to get some collection of dust that you wouldn't want to count. And luckily, you actually don't have to worry about that with your PPIs, which again, we're going to discuss. Now, important note, there are different kinds of cyclones, and they have different specifications based on whatever's needed for that particular period. So make sure that you know which one that you need for whatever flow rate you're specified to use in your sampling method. So PPIs have changed the game here. So this is the same filter and same analysis that you would use with those cyclones, but the PPI is functioning completely differently. It's not going to then matter if your employee bends over or any of that stuff. And these are just like sort of constantly being added into the methods, and it's generally, I think, accepted that these work as well as the cyclone, and they're definitely much easier to work with. So handy calibration adapter, which I mentioned a little bit earlier, don't have to worry about tipping it over. There are also different flow rate flow rate options the same way you saw with the cyclones. That helps you with that flexibility for different sampling times, and then particularly for some like silica issues. So inhalable particulate is just total dust. So this is going to include those larger particles, and it's also going to include things that can deposit sort of anywhere in the respiratory system. So just both aspects. And there's different options here for how to perform some of the sampling. This is where we're really just getting into, I want you to know that things are available. So this is that inhalable sampler, just an exploded view of it there. Then we've got, this is a button, so same idea. This is one that can do the inhalable particulates, which again is just another term for that total dust, anything that can get in there. And the inlet screen is going to be what's keeping particularly large particles from landing onto the filter, but it's still going to be collecting more than you would get if you went through a cyclone operation or through the PPI. So this is then, if you know about things that are respirable hazards, then there's specific thoracic area for what might be. So there's a thoracic PPI, there's also a thoracic cyclone. Same idea, just you're narrowing that window of what's or maybe actually broadening it, depending on how you look at respirable fraction, but you're putting it in a specific area for that thoracic area of where it's going to be deposited, if that's what's of concern for that particular contaminant. So there's a whole different world of our sampling media for gases and vapors. So this is just that definition. Gas, it's considered a gas if it's normal physical state, is a gas at room temperature. And then if the substance is a liquid at normal temperature, and then the gaseous part of it, comes off when it's, I'm not explaining this well, but a vapor is a substance that's liquid at normal temperature, and then when it starts moving into that gaseous state, it's creating a vapor off the top. It's vaporization, vapor pressure. We don't have to get into that, but you do need to know that these are collected differently. Gases and vapors are collected differently than particulates. So this is where you're going to use the most widely used one is your solid sorbents, and these are typically going to have small either granules or beads, and the idea is that as the gas or vapor is passing through, it's able to then adsorb onto the surface of this solid sorbent. So this is inside of a tube, and as the gas passes by, the air is just going to flow through, but then you're giving it enough time, and hopefully there's enough surface area in there based on, this should be from the analytical method again, for it to get exposed to that gas or vapor and then adsorb it onto the surface. And then you're able to get it off during the laboratory analysis. So when we're using these sorbent tubes, you're going to have a larger section that's your primary collection layer. So where you're collecting your chemical of concern onto that sorbent. And then the smaller section is the backup layer. You're going to have an arrow on your tube that's going to show you the direction of flow. And there's the backup layer. If you end up getting contaminant onto your backup layer, then you're concerned that you've overexposed probably, and then your representative, your sample's not really representative, right? You want to typically have not gone into that backup area. You want to have done it for the right amount of time for your exposure to then have everything collected onto that main area. So how do you know which sorbent to use? Again, this is going to come from that analytical method, and your laboratory is also who can advise you which tube to use. So there's a bunch of different types, and I don't want to get into it too much. Just understand that there are ones that are carbon-based, there are inorganic sorbents. A good example of this is your little silica packets that you see. And there are different types based on different things. But your sorbent tube, there are some advantages to that. Your sample is going to be essentially integrated over the entire period of exposure. And then you've got different published methods that have extensive documentation of why this is reliable. And then workplace compliance, this is what they're going to have used previously to set these methods, so then it's just better for comparison, right? And then your airflow is calibrated and measured. And like I mentioned previously, that backup layer, if you do get contaminant in that backup layer, that indicates that you've had breakthrough. So you had so much exposure that you went past the point of it being collected onto your sorbent. And so now you've actually, you should really redo your sampling because you don't really know how much you did. They're also impingers. So these are little special glass bottles, obviously very difficult to work with sometimes, with a collection liquid that's, again, specified by your method. And the sample pump is used to bubble air through the impinger, which is going to have that liquid in it that is going to react to whatever to physically dissolve or have the chemical essentially react. The liquid inside the impinger will chemically react with the chemical that you're concerned about exposure. Everyone, I mean, they're terrible. Everyone does hate to use impingers. Not just because they're glass, they're just a lot of trouble. Sample bags. This is just something where you go and do a grab bag sample. I've only ever done this a few times just to get some area monitoring before we've done some demolition, but there probably are a lot of other uses. This is just another image, that sample collection sample bag, how you're doing it. There's different types of these bags. And again, I just put these in here so that you have something to reference. But this is going to allow you to do sort of quick, rapid screening. So you're going to be able to collect a sample and then be able to use something to indicate if there was contaminant in that quick sample that you grabbed. So that can help you you can also send it off to a lab, but if you just need a quick check, that can be a way to do something. Then this is just an example. If you had a flow rate, you're going to have a flow rate specified for this gas, and then you're going to have a sample volume that you needed. So how do you figure it out, right? If it's 0.1 to 0.2, is it tasked for full shift sampling? What's your expected concentration? And you're going to be able to figure that out based on which flow rate you're able to select and which sort of lost track of my slide there, which sample volume is needed. We could walk through it, but I see that I'm bumping up on what I meant to end, and you did tell me that this slideshow was too long. But so who are you going to call, right? So you're going to reference NIOSH for that analytical method, and you're going to have an AIHA accredited laboratory. The lab may provide everything you need, but if you do feel like you have more questions about your sampling, then there are, I hate to say this for our guys, but there are vendors aplenty, right? Like here at OHD, you would be able to call us about an issue you were having with your sampling to ask us if it's something to do with your pumps. And if you had enough questions, you would eventually get to me, and I'd be happy to help. Okay, perfect.
Wow.
You're surprised.
But also that was very good.
Oh, great. Yeah.
I'm
very surprised. She said this was when she looked at the PowerPoint, she said that is too long and it is too boring. So I do apologize. It is just a lot, right?
But I was riveted.
Okay, it's a lot. She was riveted. I hope you were also riveted, and I finished right when I wanted to. If anyone has any questions, please drop them in the Q&A. Good job on adding your email too.
I remember this. See,
Ooh, I like that.
I agree.
I like that. Everyone's like, we have no questions. Thursday is practically Friday, and we would.
That's so true. Thank you, Cheryl.
Thank you, Cheryl. Thanks for being here.
Just a quick note, as a reminder for anyone who came in late, we are going to give you a form. Oh, we've got a question, but we're gonna give you a form. So if you want CEU credits, you're gonna fill out the form. If for some reason you joined us yesterday, thank you, Emily. If for some reason you joined us yesterday and you could not fill out the form, and you have not emailed me, please email me. My name is Laura. So lflowers@OHD Global. And now for a question from Cullen.
Helen, I know your name. Are we connected on LinkedIn? I feel like we are. In the absence of any other method availability for an analyte, do you think a sample bag method could possibly be used for short-term exposure sample? I feel like I would need more information to answer that appropriately. I mean, I want to say, I want to say that yes, like if there is no other method available, then theoretically, if you're doing a sample bag at sort of a worst case exposure level, then could you kind of interpret that for some sort of short-term personal exposure? I feel like I want to say yes, but that doesn't feel like a very confident answer. And the only reason I feel like sometimes you just gotta do what you gotta do is because you're saying if there is no other available method, which is coming up more and more, right? There's new chemicals being produced literally every day, and OSHA is obviously not keeping up, and even ACGIH, who makes a lot of effort to try, isn't able to keep up because it's literally like hundreds every day that are being created or so that's a really good question. Colin, if you want to contact me offline and tell me more about this analyte, I might be able to reach out to ACGI. I mean, I will definitely be able to reach out to ACGIH because I'm currently their board chair. So I think I could get some information for you to see if that would be appropriate for that analyte. The slides and recordings will be emailed after.
Yes, we will be sending you a follow-up. Again, if you have joined us for multiple days, you will be getting at least 2, if not 3 emails from us with all of the slides and recordings, etc.
Also have a question from Jacqueline. Do you recommend having your sampling pumps maintenance annually? Look, I'm spoiled rotten, so yes, but I'm right here, right? So I'm sending my pumps in every year and I'm getting them maintenanced. Also, that's just what I'm used to with my other instrumentation. So I recommend yes. And as far as us providing that service, it's sort of in an indirect way. Like, yes, you can send it to OHD, but we're going to send it to Sensodyne and then Sensodyne's going to send it back to us. So like, yes, we provide that service, but we're not doing that in-house.
Right. We recommend you reach out to Sensodyne, who's a manufacturer of Gillian, to initiate calibration. And if you have a Gillian pump, you should probably be getting emails from them about annual calibrations or regular.
Because I'm not even sure if that's I don't know if that's what's required. I think that it's probably not, because I know with my sound level meter, my noise monitoring equipment, I end up getting it checked every 2 years, but I'd probably do every year. But then it turns out that that's actually not required. So live and learn. Then ask Dawn.
Sensodyne is your best bet to reach out to. They're super helpful. Any other questions? So yesterday I did not leave the chat up long enough for folks to click on that form. So I'm going to leave it up just a little longer. When I say chat, I do mean the Q&A. I'm so sorry. But you can always email me if for some reason you don't click on the form. If you want to just chat, you can reach out, but click the form. That's the easiest way to do it. And we will get those CEUs to you. We'll pass those along. Thank you all for joining Safe+Sound Week. Oh, yeah, we got another question.
Can't think enough. Do you have a different method for worker safety versus community monitoring? I mean, yeah, so with worker safety, I've got the pump on the person and I'm monitoring their actual exposure as they're going about their business. For community monitoring, I'm typically measuring like around the outside of my exposure area, right? Like my facility, depending on what the community requirement is. And then there's also other standards which I'm not familiar with about, and like sometimes like, yes, it might be the same setup, but you're doing it still with a pump, around the facility to get that sort of perimeter measurement. And there can be things that are specified for what your community exposure would be. But the EPA has things where you have to look at your emission sources, right? And that's something I'm not familiar with. That's a different kind of testing that you're doing, to monitor your own emissions and make sure that you're not getting out. So yes, different method for worker versus community. Monitoring community to me would be area, and I'm going outside of, to the edges of my facility and measuring. Is that what you mean, Jason? But as far as community exposure, I would also be concerned about whatever the EPA requires for you to check your own emissions. And that's a very different beast. I don't actually have any familiarity with that.
Gotcha.
Luckily, I've never had to be the industrial hygienist and environmental person. We've had some fires that impacted both, and how we did this question. Well, first off, Jason, I would love to hear more about that. So if you could email me, that'd be great. My email is slynch@ohdglobal.com. Because I would like to know what you did, and then I would like to make sure that I'm recommending the right thing. That'd be great for me. And if not, I can find you also in the list, Jason. I'll find you and email you too, if you didn't get that.
Donna, quick question. Did you say I can't access the link or you can access the link? If anyone has trouble accessing the link, please cannot. Okay, gotcha. If anyone else has trouble, throw that in the chat. In the meantime, just email me, Donna. I've got you down. For sure. Thank you for letting us know.
Thank you, Marianne. Thank you, Donna.
Thank you, Donna. Had to copy and paste it. That's
Oh,
interesting.
interesting.
Sorry about that, guys. Thank you, Justin, for letting us know. Hey, while I've got you guys on here, while you're hopefully getting that link copied and pasted or emailing me, then oh, that's so weird. Okay. Sorry about that, Melissa and everyone. Oh, it is a Google form. Okay, gotcha. Yeah, you'll just email me, or put your names in the chat. That would actually be super easy if you just put your names in the chat. Now, if you've already talked to me, like Adam, Donna, etc., I've already got you. Melissa, I've got you. We are obviously a respirator fit testing company. We manufacture both the QuantiFit 2 and the AeroFit. The AeroFit is new to market, and we have a webinar coming up. So in that follow-up email to you, we will be inviting you to our next webinar that talks about the AeroFit, and we're really excited. So yeah.
Oh, I got a new question.
Got a new question.
Although ACGIH no longer has a short-term exposure limit for benzene, what recommended value would you say would warrant the use of RP for short-term exposure? Ooh, I'd have to look. I'd have to look, Tisha. I'll find your email on the list and I'll look and get back to you.
Make a note.
Thank you.
Yeah, awesome. Yeah, keep throwing those names in if you need it, or just email me. Like I said, that's really cool. Sorry about the form, and thanks everyone for joining. We really enjoyed this week.
Yes. See you next year at the latest, right?
Next year at the latest, hopefully next month for the AeroFit webinar though.
Yes.
Which Dr. Lynch will also be on.
But other people too, in
And
case you're just tired of hearing my voice, which I'm tired of hearing.
Totally fair.
That's totally fair.
Awesome. Thanks, guys.